Saturn, one of the most mysterious planets in our solar system. Now the Cassini-Huygens mission is exploring this enigmatic world and its moons. For the first time, it allows scientists to see what lies below Saturn's upper atmosphere and investigate the origin of its incredible rings. A probe touches down on the largest moon, Titan, to search for a world like our own and the possibility of life.
Five, 4, 3, 2, 1, and liftoff of the Cassini spacecraft.
4:43 a.m. October 15th, 1997. An 1,100-ton Titan 4B rocket launches from Cape Canaveral. It carries with it Cassini-Huygens. Its destination lies almost 900 million miles away, at the awe-inspiring planet, Saturn. A huge gas giant, orbited by at least 60 moons. Saturn is the second largest planet in the solar system, over 750 times more massive than Earth. It's a gassy world without solid surface. The last mission to this mysterious planet launched over a quarter of a century ago. The Voyager spacecraft sent back these images, showing a planet shrouded in thick banded cloud. Onboard infrared cameras spot what looks like storm activity beneath the haze. Something big is brewing on Saturn.
The problem with Voyager missions is that they were flyby missions. They were one-time snapshots.
Voyager can't stop to investigate. Its flight plan is fixed. Scientists can only gather limited data. Voyager 1 also skims the atmosphere of Saturn's largest moon, Titan. Scientists are shocked at what it finds. Its instruments detect organic compounds in the atmosphere. These are similar to the compounds that provided the raw material for life on Earth 4 billion years ago.
In a way, Titan is a glimpse back in time to processes that may have been occurring on the early Earth that may have led to life.
But once again, Voyager 1 can't stop to investigate. It hurtles off at 39,000 miles per hour into the cold outer reaches of the solar system. The Voyager mission makes tantalizing discoveries, leaving scientists with more questions than answers. They are determined to return to the mysterious moon and take a closer look.
We want to understand our own origins. We want to understand why the Earth came to be the way it is and how life came to develop here.
Scientists believe by unlocking some of the secrets within Saturn and its moons, we could learn how our own world developed and how life began. Cassini is one of the most scientifically advanced spacecraft ever launched. It will explore Saturn's atmosphere using an array of high-tech cameras and sensors. Cassini carries with it a probe called Huygens. This will deploy to Titan, Saturn's largest moon. It will plunge through the thick atmosphere and land on its surface. But first, Cassini must make the long haul through 2 billion miles of space. The mission control team used the gravitational pull of our neighboring planets to slingshot the spacecraft around Venus, Earth, and Jupiter, giving it enough momentum to reach Saturn. After 7 years of flight, Saturn looms into view. Cassini captures this stunning image of the gas giant. But before it can get close enough to begin its detailed exploration, Cassini must pass through the rings. The rings are chaotic and dangerous. Made up of billions of particles of ice and rock, circling around the planet at high speed. Some chunks are as big as houses. The only way through is to navigate a gap between the rings. Dr. Jeff Kuzi is in mission control as Cassini approaches the gap.
The gap isn't something you would see with your eye. So it wasn't exactly like there was a huge, tight tolerance, a narrow, threading the needle kind of a thing.
Tension builds as the high-risk maneuver begins. Cassini fires its rocket engines to position itself and heads for the gap. Its antenna points away from Earth. Communication is temporarily lost. Dr. Larry Esposito waits for the signal to return. The sign that Cassini has made it through in one piece.
Everyone was holding their breath, waiting for the signal to come from the spacecraft to show that it had successfully passed through the ring plane.
Several hours later, they get the signal.
The Doppler has flattened out.
Cassini has made it through.
Once that happened, the silence ended, broke into cheers, applause. People hopped up, shook each other's hands. Some people hugged each other. It was a great moment of success after decades of planning.
For the first time, a spacecraft has entered orbit around a planet in the outer solar system. And for Dr. Tony Del Genio, it's in the perfect position to start exploring this gas giant.
The beauty of the Cassini mission is that for the first time, we get to go into orbit around a planet like Saturn, and for years observe it over and over again from different angles, and by putting that together over this long period of time, finally some of the secrets start to be revealed to us.
The first task is to explore what lies beneath Saturn's thick upper atmosphere. Cassini maneuvers towards the South Pole. There, its instruments reveal an unexpectedly familiar phenomenon. A monster hurricane-like vortex. This actual image clearly shows the storm and its scale.
This feature is more than 1,000 miles across, so many times the size of a real hurricane on Earth. And what you're seeing is a sequence of images showing the clouds rotating around the South Pole.
This is the first hurricane-like storm ever detected on any planet other than Earth. Like hurricanes on Earth, it has an eye circled by a gigantic column of cloud. But this one towers 45 miles high. Around it, winds rage at 350 miles an hour. Cassini's cameras zero in on the high-altitude clouds in the upper reaches of the eye wall. Temperatures here are minus 167 degrees Fahrenheit. The pictures capture what must be a flurry of ice crystals. Scientists are enthralled. Like Earth, Saturn has storms with swirling clouds, strong winds, and even snow.
It definitely snows on Saturn in the upper reaches of the storm systems that we see. I think we're pretty confident that there would be large ice crystals. When you got down much deeper than we can see to in the images, then we would expect actual liquid water rain to be falling out of the bases of those clouds.
On our planet, hurricanes are fueled by the ocean and ultimately the sun. Saturn is far too distant to draw the kind of solar power its monster storms need. So what drives them?
When you get into a gas giant atmosphere like Saturn, once you get a wind going, you can maintain it for a long period of time without a solid surface underneath it to dissipate it very quickly. But still, slowly over time, if you didn't somehow put energy into the system, the winds would still dissipate.
Now scientists investigate the theory that the energy for the storms comes from deep inside the planet. It's a theory they've never been able to prove. But at a laboratory in France, an extraordinary experiment is trying to verify its basic principles. Cassini captures these images, showing a monster storm on Saturn. A gigantic hurricane 2/3 the diameter of Earth rages at the planet's south pole. Winds encircle the central eye at over 350 miles an hour. Scientists want to know what fuels these storms. Saturn is too far from the sun for them to be driven by solar energy. The power source must lie elsewhere. Many scientists believe it comes from deep within the planet. At the Coriolis Laboratory in France, astrophysicist Peter Reed searches for evidence to support the theory. He is using an internal heat source to recreate Saturn's turbulent atmosphere.
The overall objective is to try to come up with an understanding of what processes actually drive the winds and organize them into banded structures, and into these sets of alternating eastward and westward jet streams on Saturn and the other gas giants.
Inside this huge rotating tank is almost 40,000 gallons of fluid. This acts like Saturn's gases. A heater sits in the base of the tank to simulate a heat source deep inside Saturn. Suspended in the fluid are tiny light-sensitive particles.
So these particles act basically clouds in Saturn's atmosphere, so they'll be carried around by the winds, and this will help us to actually trace out where the vortices and the jets are actually occurring.
Reed wants to see if currents and vortices develop in the same way they do on Saturn's surface. The tank spins to mimic the rotation of the planet. The tiny particles start to spread out and interact. Slowly, the particles begin to swirl and create vortices.
Okay, so we can see evidence of a jet structure, and then here we can see a very nice rotating structure, which is basically an anticyclonic vortex.
Compare these to Saturn's twisting patterns of clouds. The similarities are striking. Reed's experiment suggests that a heat source within Saturn could fuel the raging storms. But what lies in its center that could generate that much heat? The gas giant is approximately 75% hydrogen and 25% helium, with traces of water, methane, and ammonia. Scientists believe that, like Earth, Saturn has a hot core. Earth's internal energy comes from radioactive materials in the core and residual heat from its formation. But here on Saturn, scientists think heat is generated by highly pressurized gases. Deep down in Saturn's atmosphere, the pressure of the gas builds. Near the core, the pressure is several million times higher than on Earth's surface. It's so powerful that the hydrogen and helium gradually turn from gases into strange metallic liquids.
If you get deep enough, then the hydrogen and helium become so dense that they don't behave like a gas anymore. They behave more like an electrically conducting metal.
This liquid swirls around a rocky core that is roughly the size of Earth. But just as oil and water can't mix, the liquefied metallic elements can't hold together. The heavier helium separates and sinks through the hydrogen. Scientists believe this movement creates friction that generates heat. Cassini is looking for evidence supporting this theory by measuring the precise abundance of helium in the atmosphere. It's already amassed a vast amount of data. There's so much that it will take years to analyze. Scientists hope to find out for certain how Saturn can give out 3 times more heat into space than it receives from the Sun. Cassini is unveiling Saturn's turbulent activity in unprecedented detail. Now its main engines fire, and mission control steer the spacecraft outward to explore one of the greatest mysteries in the solar system: Saturn's chaotic rings. Saturn has the largest and most spectacular rings in the solar system. The Voyager missions first revealed their awesome scale more than 25 years ago. The Voyager spacecraft show that the rings are chaotic. They're made up of billions of chunks of ice and rock colliding into each other.
If you were to fly over the top of the rings very close so you could actually see them, you'd see something that would look a little bit like a flying boulder field. Small particles ranging between a fraction of an inch in size and maybe a couple of yards across.
The turbulent rings got scientists thinking. The particles orbiting Saturn resemble the disk of gas and dust that encircled our young sun 4.5 billion years ago. The particles started clumping together, growing larger and larger, until after millions of years, they eventually formed the planets in our solar system. Could the same process be occurring inside Saturn's rings? Is this a good analogy for how planets may grow? Cassini sends back these stunning, highly detailed images.
I was very excited to see these beautiful, beautiful images. We're going to learn a huge amount just from the first couple of images.
Cassini uses an ultraviolet imaging spectrograph to map out the ring's structure with remarkable clarity.
The spectacular detail that we saw was just an eye-opener, and we stood amazed to see the structure that was in the rings, much more than I had personally expected.
As the particles pass in front of distant stars, the UV spectrograph measures the amount of starlight shining through. Areas that contain a lot of particles block starlight and appear darker. Where there are fewer particles, more light passes through. Scientists interpret the darker regions as temporary clumps of ring particles. They are known as moonlets. Cassini captures them on film for the first time. They appear as bright lumps within the rings.
These big boulders may very well be nothing but an agglomeration of the smaller ones. And these agglomerations may come and go with time as they bump into each other. They may just fall apart and collapse, and then they may reform by their own gravity and stickiness on the surfaces.
Scientists are fascinated by the images. They think this process happened in the early solar system. 4.5 billion years ago, the planets grew from microscopic specks to the size they are today.
The interaction between the moonlets and the ring particles is exactly like the interactions between a planet and the dust that's collecting to make that planet grow.
Cassini's spectacular images offer new insight into the processes behind the formation of our own world and the entire solar system. But where did all the material that makes up the rings come from? In its infancy, the solar system was a violent place. Comets and asteroids regularly collided with young planets, creating massive explosions and leaving behind scars that we can still see today. This image, modeled from real data, shows Saturn's tiny moon, Mimas. This giant crater dents its surface, a scar from a gigantic impact. Mimas was lucky. It survived the impact. But scientists think that Saturn could have lost one of its other moons completely, shattered into billions of fragments.
Imagine an object coming in that's the mass of a small planet or a big comet coming in. There's a huge amount of energy there. It could actually rubbleize it pretty well.
Saturn's powerful gravity could have captured the fragments and over time compressed them into a flat plane around its equator. These strange rings may be the result of the solar system's most intense period of planetary bombardment. They may also unlock the secrets of the solar system's birth, 4.5 billion years ago. Cassini's next stop provides scientists with another opportunity to step back in time, to a world like Earth before life evolved. This is the mysterious moon, Titan. Cassini has crossed over 2 billion miles of space to reach Saturn and its moons. It carries with it a secondary space probe called Huygens, designed to land on Titan, one of Saturn's 60 moons. Titan is massive. It weighs almost twice as much as Earth's moon. It's an object that's perplexed scientists for decades. In 1980, Voyager 1 sends back these intriguing images of a world shrouded in a thick orange atmosphere. Analysis reveals that this is mostly made up of nitrogen, just like Earth's. The spacecraft also detects water and traces of organic compounds like ethane and carbon dioxide. Compounds that could provide the raw materials for life. Titan's atmosphere appears to be remarkably similar to that of early Earth. Now Huygens returns to pick up where Voyager left off, to search for signs of life. Dr. Carolyn Porco was a young PhD student on the Voyager missions.
You can imagine that for those of us who had been involved with the Voyager mission 24 years earlier, that there's a tremendous amount of anticipation in returning to the Saturn system.
Cassini's sophisticated cameras alone can't fully penetrate Titan's thick atmosphere. What's on the surface beneath the thick haze?
Our first pictures of Titan were very mystifying. In fact, our images are painted on this globe, and it's very difficult, if you look in detail, to see exactly what you're looking at.
Cassini's probe, Huygens, is designed to solve this mystery. The probe hits Titan's dense atmosphere at over 13,000 miles per hour. At first, its cameras only transmit these images of a thick yellow haze. But at around 30 miles up, Titan's surface comes into focus.
It's just very difficult to describe accurately what it was like to see the first images that they showed of the surface of Titan, because they were mind-blowers.
These images show an extraordinary desert-like landscape with low hills and rolling plains. But mission engineer Dr. Ralph Lorenz worries where Huygens will touch down.
We had no idea what it was going to land on. We didn't even know if it would survive landing. It could have landed in a lake of liquid hydrocarbons. It could have landed on a solid sheet of ice or a sand dune.
To the relief of all, Huygens lands on level ground and survives. It's the first probe to touch down on another world in the outer solar system. Onboard cameras reveal an eerie alien landscape. Lorenz rigged the probe with an instrument to analyze the composition of Titan's surface.
One thing it did is it had an instrument called a penetrometer, which was rammed into the ground and told us how hard the surface was. The texture was like damp sand or even a soft clay, and there were indications that there might have been a pebble or a crust on top, and there was even the joke that the surface was made of creme brulee.
The penetrometer reveals Huygens has touched down on soft ground, but not just any ground. Its camera shows smooth, round rocks, similar to those found in a riverbed.
There were a lot of rounded pebbles around, and the way you get rounded pebbles is that they're tumbled in a stream. And so this area, which had river gullies, must have been rained on sometime in the past, and the rain washed down, tumbling these pebbles.
Huygens discovers signs of liquid on the moon's surface.
So right away, there was this unambiguous sign of a process that we knew how to interpret. So this was tremendously exciting. It said there had to be liquid something flowing on the surface of Titan.
But is the liquid water? Huygens thermometer registers the surface temperature as 290 below zero. In this bitter climate, water would freeze as solid as rock. But if water didn't carve this riverbed, what did? As Huygens continues to probe from the ground, Cassini moves to the moon's uncharted North Pole. Its radar penetrates the smoggy atmosphere to reveal dark patches. These indicate something astounding. Lakes. Liquid may still flow on Titan's surface. But what liquid can withstand freezing temperatures? Cassini's visual and infrared mapping spectrometer picks up a dramatic cloud system. It's enormous, engulfing almost the entire North Pole. Scientists suspect these clouds could supply the liquid that appears to fill Titan's lakes. Cassini homes in on the clouds and finds they are made of methane. It seems that Titan's surface has been carved not by water, but by liquid methane.
We've counted up the volume of liquid in some of these lakes, and it's hundreds of times the amount of all the liquefied natural gas, all the oil on Earth.
The super cold temperatures on Titan allow methane to exist as a liquid. Any water on this moon is frozen solid. Surface conditions are not conducive to life. But Titan's atmosphere is another story. Scientists focus in on the tiny particles suspended in Titan's atmosphere, first discovered 25 years ago. They are a cocktail of organic molecules, the stuff of life. Molecules like these existed on Earth 4 billion years ago. If scientists can understand how they form on Titan, they can figure out how they developed into life on Earth. Cassini isolates the exact mix of molecules and transmits its findings back to mission control. Astrobiologist Dr. Chris McKay has been trying to recreate Titan's atmosphere in the lab, using the data from Voyager.
As soon as the Cassini results came in, we scrambled to change our experiments to line them up with the new information. It was like working on a problem for a decade and then finally seeing a glimpse of the answer in the back of the book and realizing, aha, this is the way to go.
McKay now tries to use this formula to turn simple organic molecules like methane and nitrogen into the building blocks of life. In his lab, he simulates Titan's pressure, temperature, and nitrogen-rich environment.
Here is a tank of methane and nitrogen. This is the starting mixture for Titan's atmosphere. It flows through the apparatus into our reaction chamber. So now I'm going to turn on the energy source, and this flow of methane and nitrogen will experience the same kind of energy processes that are going on in Titan's upper atmosphere.
Then McKay uses electricity to simulate the sun's ultraviolet radiation.
We have Titan in a jar.
After a few hours, the simpler molecules turn into complex nitrogen-rich substances called tholins. These lab-made tholins are almost exact copies of those found on Titan. Understanding how they form gives us valuable insight into the origin of life on Earth.
One overall question in studying Titan and comparing it to the early Earth is the question of how unusual is the sort of chemistry that led to life on Earth? Is it very rare and it happened on Earth because of very unusual circumstances, or is it commonplace organic chemistry that we can expect on any world that's like Earth or even like Titan? And if we find that there's a common theme, a common way in which this kind of process goes, maybe the steps that lead to life are commonplace, and therefore life is commonplace.
The Cassini mission to Titan reveals how life could emerge on other worlds. On the surface, Huygens batteries die out. Its landing represents one of the great achievements in the history of space exploration. Huygens provided a spectacular view of Titan and returned over 750 images and over 3 hours of data. Cassini abandons Huygens on Titan and heads for another moon, which scientists believe could be its greatest conquest, Enceladus. Cassini continues exploring the Saturnian system. In its sights, the moon Enceladus. Covered in ice, Enceladus is one of the brightest objects in the solar system. Cassini's cameras captured these detailed images of this dazzling, frozen world. Its ancient, wrinkled surface is made up of fractured plains, craters, and folded mountains. But as it skims past, Cassini's magnetometer registers some kind of disturbance. This is the actual recording. The moon creates fluctuations in Saturn's immense magnetic field. But how? The magnetometer detects gas coming from the moon's surface. Experts suggest it must have some kind of partial atmosphere. Planetary scientist Professor Bob Brown thinks this is impossible.
They said, hey, we're seeing evidence of a tenuous atmosphere around Enceladus. And many of us responded with skepticism because an object like this can't have an atmosphere.
Enceladus is just 300 miles across. It has too little gravity to hold on to an atmosphere for very long. But things are about to get stranger.
The magnetometer group told us the atmosphere around Enceladus seemed to be concentrated around the South Pole, which is even weirder. Atmospheres don't do that. They distribute themselves uniformly around an object.
The team is mystified. What could create a strange, localized atmosphere? Cassini moves closer. The spacecraft captures this stunning image. Giant geysers on the surface of the moon appear to throw out huge plumes of vapor. The unidentified gas blasts over 400 miles into space.
To see this image, okay, where we have a dozen to 24 jets, narrow jets, just emerging from the South Pole, was, it's one of those things that a person who lives the kind of life I lead lives for. Okay, it was just one of those discoveries that, you're not going to make often in your lifetime.
Cassini's spectrograph analyzes the vapor of the jets. It contains water. This discovery is completely unexpected. Could liquid water exist on this frozen moon? Cassini is looking for liquid water on Enceladus. It zeroes in on an area of the moon covered with cracks.
But one of the things that was absolutely stunning about this is that when we got into these areas where these cracks are, they're clearly a lot warmer. It may very well be that the temperatures there are as high as 0 degrees C. It may very well be that they're high enough that liquid water is literally very, very close to the surface.
Cassini has found a hot spot, an area warm enough to support water in its liquid form.
That was just, mind-blowing. Like, what could be possibly producing this? It's one thing to find a body to be warm. It's another thing to find that it's only warm in one location.
Scientists are baffled. What generates these pockets of heat? Enceladus's orbit is elliptical. Its distance from Saturn varies over time. One theory is, as it passes close to Saturn, its crust flexes. Then as it moves away, it relaxes. Friction at the fault lines generates heat. Perhaps enough heat to melt ice within the faults.
Enceladus flexes its body, okay, and so that can produce friction enough to melt ice, to create liquid water.
The prospect of liquid water on one of Saturn's moons demands further investigation. The first step is to determine the exact composition of the plumes. Mission Control fly Cassini just 30 miles above the moon's wrinkled surface, passing through the geyser's outer edge. Its instruments measure the composition. The results are completely unexpected. The plumes contain water vapor, nitrogen, and even simple organic molecules.
It doesn't take much of a jump at that point to make the association that if you have water, you have heat, and you have organic chemicals, you have the conditions that might actually produce primitive life.
Scientists now believe that Enceladus has conditions that can sustain life. Living organisms could survive around the warm faults that sit at its southern pole. The latest theories suggest that the faults in the terrain here may stretch down to a subterranean sea. This would be a dark world devoid of sunlight, but life may still have emerged here. On Earth, primitive organisms thrive in similar hostile and extreme environments. Scientists speculate that the same could be true of Enceladus.
There's the possibility of having something akin to those hydrothermal vents that we see at the bottom of the ocean. And we know there are living organisms there. There's chemistry that goes on there that living organisms can utilize to live.
It's a tantalizing possibility. If there are living things on Enceladus, the implications would be profound.
What could be a more important scientific discovery than to find out life has evolved separately in some other place? That changes the whole picture for human beings.
If we could demonstrate that the origin of life, Genesis, had occurred twice independently, then as far as I'm concerned, the spell is broken. We could safely infer life had occurred an astronomical number of times throughout the cosmos in its 13.7 billion year history. So this is why it is such a pressing question for us.
Cassini shows us that life may be possible on alien worlds. On April 15, 2008, more than 10 years after launch, NASA announces that the mission will be extended for a further 2 years. Parts of its tour will be dedicated to the exploration of Enceladus and Titan. Perhaps it will make the biggest discovery of them all: life on another world.